In this video, we're going to solve sample exercises 7 and 8. So let's start with sample exercise 7, and we're asked to find the number of moles. So we're asked how many moles of sodium bicarbonate there are in 500 grams of sodium bicarbonate. So first we will need to find the molar mass of this. So that's our conversion factor whenever we're going from grams to moles or moles to grams. So we have 1 sodium, 1 hydrogen, 1 carbon, and then 3 oxygen. So 1, 1, 1, and 3. This we know is 16. This we can look up on the periodic table is 12.01, 1.01, and then I don't think we've seen sodium in the past in a video, so 23 grams per mole for sodium. So we would add all these up. So we have 40 plus 12 plus 1 plus 23. We find the molar mass for sodium bicarbonate to be 84.02 grams per mole. And that will help us with our conversion. So we start with what we're given here, 508 grams of sodium bicarb. We will multiply by the conversion factor. So for every 1 mole, I have 84.02 grams. And I set it up this way utilizing the conversion factor, so they will cancel out the unit of grams, and I'll be left with blank moles here. So I have 508 divided by 84.02, and I see that I have about 6.05 moles of NaHCO3. So we're going to look at the next sample exercise here, which is multi-part. And first we're asked to find what the mass is in grams of 6 moles of sodium bicarbonate. So we've just calculated the molar mass, so it's actually 6.33 moles. So we write out first, we start with what we're given, and we know that for every 1 mole, the mass is that 84.02 grams. So now my moles will cancel, and I end up multiplying the numerator. So 6.33 times 84.02, and I have about 532 grams of course, sodium bicarbonate. In our next example here, so part B, we are given a number of moles of sulfuric acid. So to find our conversion factor, first we need to find the molar mass in grams per mole. So sulfuric acid has the chemical formula H2SO4. So I have 2.02 from my 2 hydrogens. I have 16 times 4, or 64, from my oxygen. And then sulfur is 32.06 from the periodic table. So I add up all these values, and I find that the molar mass is approximately, where am I? 98.08 grams per mole. So now if I have what I start with here, 3.0 times 10 to the negative 5th moles, and for every 1 mole I have of H2SO4, I have 98.08 grams. So I'm going to cancel out the moles, multiply 3 times to the negative 5th times 98.08, and I end up with approximately 2.9 times 10 to the negative 3rd grams. We could write that in decimal form, 1, 2 zeros, 29 grams. So either of these forms show us our mass of sulfuric acid when we have 3 times 10 to the negative 5th moles. And there's one more sample exercise that is very similar. So we'll take a look here to how many molecules are in a certain mass. So these are similar in the sense that we may need molar mass to use as a conversion factor to get to moles of our substance before we can convert to molecules. So I already have the molar mass for nitric acid. So let's set this up, starting with what we're given, 4.20 grams of nitric, HNO3. the molar mass. So we have 14.01 plus 3 times 16 plus 1.01. That gives us our molar mass of 63.02 grams for 1 mole of HNO3. And then if I want to know how many molecules I have, I know that in every mole of HNO3, I have the same number, 6.022 times 10 to the 23rd molecules. So I'm going to multiply after I divide by 4.2 by 63.02, then I'm going to multiply by Avogadro's number, and I should find with proper rounding and sig figs that I have about 4.01 times 10 to the 22nd molecules of HNO3. So now I want to know how many oxygen atoms are in this sample. So the same sample, the same mass, that 4.2 grams. So now I'm going to start at this point where I know how many molecules I have. And I'm going to look at the chemical formula to find my conversion factor to oxygen atoms. So if it's HNO3, for every 1 molecule of HNO3, I could say I have 3 oxygen atoms. So 3 is multiplied on top, and then we would end up after we multiply 3 times 4, we get 12. So I'm going to rewrite this in scientific notation as 1.20 times 10 to the 23rd oxygen atoms.